All right, so today we're going to be looking at creating a table, basically filling in the chart or the table with the right values based on some kind of given situation from a word problem. So we've been really working with tables and looking at x and y values, how they relate. We learned about finding a rule and then writing an equation. But again, that was just for numbers that didn't mean anything to us. So now we're going to start to make the transition to actually putting some meaning to the numbers. And so we're going to start to look at some situations where we can chart out all the different pieces that'll eventually be put into an equation. And this is just all going to tie together with, can we come up with an equation ourselves for a given situation using all our knowledge that we've built up now from the tables and the rules? What does the equation look like that's going to mimic those values? And then also, can we use that equation to actually solve now a real world problem? Maybe a couple different ways. So that's where we're headed. So today we're just going to be given a situation. Like number one, there's a tow truck being called. And today we're just going to start filling in these pieces to the table. And hopefully you'll start to see the different pieces and how they're actually going to go together and create one of these equations that we're so used to seeing now. So number one says a tow truck's called and the cost of the service is $10 plus $1 per mile that the car must be towed. So just to break this down, make sure we're all on the same page. When this tow truck's called, just for them to show up, that's going to cost $10. That's called a service charge. Then they're also going to charge you $1 for every mile that you're towed. So if you're not towed very far, it's not going to cost a whole bunch. If you were towed, a couple hundred miles, then it's going to cost you a couple $100. Plus, you always have to pay that $10 service charge. So even if they only tow you a mile, you still got to pay that $10 service charge. Or if they tow you 100 miles, you still have to pay that $10 charge one time. Then it's $1 per mile. So that's what this says. So in this chart, we've got a couple different situations, different miles that you were towed. We're going to show how do we find out the cost of the miles, what's the service charge in each situation, and then what's the final cost altogether for each one. So if we start with the service charge we just talked about, that's going to be $10 whether they tow you 0 miles, 1 mile, 10 miles, or 50 miles. It doesn't matter how far they tow you. If they show up to give you some help, it's going to cost $10. So I'm going to automatically put 10 for every single one of these because it doesn't matter how far they tow you, the service charge is still $10. And what we're going to call that is the constant. And when we eventually build an equation with this, that's actually what that piece is called, is the constant. And you can understand why it's called a constant. It's because it never changes. It's always $10 no matter what. And so when we're calculating a final cost, we're going to be charged for the miles, but then we always have to tack on or add that service charge. So I'm going to go ahead and put a plus here because I'm going to take this column plus this column, and it's going to equal my final cost. Now, how do I calculate the cost of the miles? Well, it's $1 per mile. So every mile I'm charged $1. So every single situation, the price is the same. It's $1 times however many miles they've towed us. So I'm going to go ahead and put a 1 times on every single column here. So now not each one of these situations costs $1. But it's $1 times however many miles you've actually been towed. So I actually want to work backwards here and come back to 0 because sometimes 0 can be a tricky one that we can kind of argue over. So I want to start with just 50. So when you're being towed 50 miles, there's that $10 service charge, but you're also being charged $1 for each one of those miles. So you need to do $1 times 50. Now, we can go ahead and we can put that answer down here if we want. That's going to be 50. And then plus 10 gives me a total of $60. So I'm being charged $60 here in total, $50 for the miles, 10 for the service charge. So if I was towed 10 miles, it's $1 times all 10 of those, which is just $10 for the miles plus $10 for the service charge. That's $20 total. If I was only towed 1 mile, then I'm being charged $1 for that mile, plus the $10 service charge, so total final cost $11. And now 0 miles, and here's where some people can just get a little too literal with this. Okay, we don't need to argue over, well, if I was towed 0 miles, would I be charged at all? we're basically trying to build an equation here. So 0 is a value that we could plug in. And so if we plugged in 0, all right, they didn't tow you anywhere, so you didn't have to pay for any miles, so that's 0. But you did have to pay the $10 service charge, so that's $10. Okay, and so we don't want to take this too literally and just get into, well, if they didn't tow me, would I have to pay the service charge? All right, so we don't want to get too in depth with the realistic side of it or not. But even if you were, if the tow company was called and they showed up and your car wasn't working and they actually showed up and they helped you get your car started, they're still going to charge you that service charge even if they didn't have to physically tow you. So you can look at it like that. So if you take a look at this equation that we've kind of built, it's this plus this equals this. Service charge never changes, so it's called a constant. Okay, this $1 never changes, but the actual number of miles is what changes. So the miles is called the variable because it varies. And I spelled that wrong. 1 R in variable. Okay, so that's the variable. And then this, of course, $1 is what goes in front of our variable. It's getting multiplied, and that's our coefficient. And those are important parts of every equation that we're going to write. There's going to be a constant being added or subtracted. There's going to be a variable that changes in every situation, and that would be represented by an x or whatever letter we choose once we get there. And then the coefficient is the number being multiplied by that variable. Okay, and that's going to stay the same in every situation. So the cost of the miles is always the same individually, and it's just changing based on how many miles we go. All right, so let's look at number 2. Your new job is at the t-shirt shop. For each order, they're going to charge you $8 per shirt, so every shirt's $8. Plus, there's an initial setup fee of $15. And I've actually dealt with this before. You call the t-shirt place and you have a logo you want them to put on your shirts. They charge you for putting that logo into the computer because it takes someone that they're paying at their shop time to get it uploaded off your email or whatever and put into the system. And then sometimes it needs to be worked with and edited in the program itself that actually prints these on the shirt. So they charge you a fee to get that set up. And then it's $8 per shirt. So even if you only want to get one shirt, you still got to pay that setup fee. Where if you're buying a ton of shirts, $15 setup fee is no big deal when you're going to print off 100 shirts. It's just a tiny little fee. But for one shirt, it seems like a lot. The actual setup fee costs more than the shirt itself. So this $15 is every situation. It doesn't matter how many shirts you order. So that's our constant. So let's go ahead and put our constant in here. It's going to be plus 15 on every single one of these. Okay, and we're going to add that to the cost of the shirts, and that gives us a final cost. Now the cost of the shirts, it's always $8 each. So I'm going to go ahead and put that 8 down here. Now that's not going to be the total cost of the shirts. That's just each shirt. So it's going to be $8 times however many shirts I'm ordering. So this one is going to be times 300 shirts, and this is times 40, and this is times 1, and this is times 0. So again, let's work backwards. So let's say 300. You say, why would I order 300 shirts? Well, what if we're ordering shirts for the entire school? The whole school is getting Montague shirts that are going to match. Okay, so we may all contribute money, and so no single person is paying this entire amount, but the school has to pay them this after we've collected the money. We're buying 300 shirts. So 300 times 8, don't grab your calculator, 8 times 3 is 24, add the zeros, so this is 2,400 plus the setup fee, so a final cost of $2,415. If you ordered 40 shirts, so maybe it's just for 2 classes, or maybe this is just for I don't know, the volleyball teams. Okay, there's 40 students total, so we're ordering 4. 8 times 4 is 32, add the 0. It's $320 for the shirts, plus 15 for the setup fee. All right, and that's a total of $335. Or if you just bought one shirt, 8 times 1 is clearly just 8, but you still had to pay for that setup fee. So you got to add the 15 in there, and that's a total cost of $23. Okay, now your 0. If you're just running the numbers, 8 times 0 is 0, plus 15 Total cost $15. But you say, if I didn't actually get a shirt, why am I paying $15? And I hear you. All right. And if we're going to get real literal with it, you may be right. We're not paying anything. But for the sake of this, we don't want to think too deeply about it. We just want to make sure the equation runs the same every time. If we were going to look at it, you call the company, you get it all set up, you're going to pay that fee up front. You're usually not going to pay it all at the end. They're going to charge you that $15 fee up front. And then you say, all right, now how many shirts do you want now that we've got it set up? So you've already paid that $15 fee. And then you decide, you know what, I don't want the shirts. Well, the $15 is already gone. So there's your final cost. But again, we don't really need to get that deep into it. Just run the zero like all your other ones. So up here, let's label, we got our constant. Okay, the actual shirts is your variable because the actual number of shirts is changing. And the $8, the cost of those shirts, is your coefficient. So we're going to keep labeling those so that when we actually get to the point that we are writing an equation from this situation, that we can kind of piece those together rather easily. All right, number 3. When a plumber's call, the cost of the service call is $50. That's the constant. Every time he shows up, it's $50 up front. So let's put the plus 50. Okay. Plus $25 per hour. Now the hours is going to change every time. So that's your variable. $25 for every single one of those hours is your coefficient. So you're going to multiply the number of hours by 25 every single time. Okay, so you multiply 25 times however many hours, you add 50, there's your final cost. So if it was 0 hours, okay, he shows up, it's $50. I mean, it's just going to cost him gas to get there, so they give you this service charge. You get there, he looks at it real quick, maybe it takes him 5 minutes. He gets something fixed, and he says, you know what, I'm not going to charge you for the hour, but there's still that service charge because I came all the way out here. So the hours, he didn't charge you at 0, but it's $50 still because he came all the way to your house. Or let's say he works 1 hour. Well, that's going to cost you $25 for that hour plus the service charge, so it's $75. If he works 5 hours, 25 times 5 is $125, plus the 50 is $175. Okay, now you'll notice on this one, this last one, I didn't give you the hours here, I gave you the final cost. So we need to work backwards and fill in the number of hours. So if we paid a total of $275 as our final cost, that includes the service charge, that includes the hours, okay, how many hours did I actually spend? So what we want to do is we want to work backwards. So if the whole cost was $275, we know we paid $50 for the service charge. So before we start worrying about how many hours there was, we need to take off this service charge. So working backwards, we're going to actually minus 50. We're going to take that 50 off the 275. So that's going to leave me with $225. Because if I did 225 plus 50, that gets me 275. So what this 225 represents now, same as this, 0, 25, 125, is the total cost of the hours. So each hour was 25. The total cost of those was 225. Now here we multiplied to get this. So if you're working backwards, think about what you should do. You're dividing by 25. So 225 divided by 25 is 9. Okay, so 25 times 9 is 225. So I go backwards, I divided. So my total hours here is 9 hours. All right, the rest of this is your classwork. Fill these in just like we did these first 3 problems. When you finish that, you can get your homework.